Okay, guys, let's start with today's day one session. Before beginning with the actual training, let me introduce myself. My name is Ambasa, carrying 20-year experience. I do deliver training for Oracle, Postgres, MySQL, along with the MongoDB and the cloud technology like AWS as well as OCI. So today's agenda, we will have to know that Oracle database performance tuning. In this particular topic, what all as a DBA, I should start my journey to handle this performance database related issue. I will just go through the course content, what it will be delivered. Open this website. You have to go to the courses. In that, you have to search with the Oracle performance tuning. So here is the section Oracle database 19C performance tuning training. And if you click on this view more info, there the PDF gets open. There you will see the list of topics which has been mentioned will be covered in this particular training. Starting with understanding about what are the tuning tools. And today I'll just go through those points. What is the SQL trace or auto trace, and followed by different execution plan. When to say it's a bad query, identify your bad query, interpretation of the execution plan, understanding about the optimizer, how it will be get influenced, what exactly it looks for when it has to decide with a good plan. Statistics as well as the hints is a separate topic. Plan stability, in that we will be going through stored outline, SQL profile as well as SQL baseline. Along with that, SQL patch and SQL tuning set. And we will also understand about how do I transport this each object from one database to another database. And going forward, we will also note that if you are not sure how to do the manual tuning, but you will learn it. But in case if it is not permitted time, you can also use the advisory. Advisory will help you out how to go ahead and tune your query. So the given query which is not working as expected, so you can take help of the advisor. You can also test before and after by using this performance analyzer. You can also use SQL plan management, tuning the memory and tuning the different areas of memory. Understanding about the IO, why we important is IO, and AWR. In depth, we will go with the AWR interpretation. You will also understand about the ASH, AWR, ADDM. Different report has different information. When to use which one, we will discuss the same. So make sure that you will be understanding this in depth, and also you will be noting down in depth this analysis part. And there are certain parameters which will make the problem in performance if you are not set properly. So those parameters we will be discussing. And query optimization will be runtime decision will try to change it, which other word is called adaptive query optimization. And that is what we will be learning in depth with noting down adaptive plans and SQL plan directives and also the wait events. What are the common wait events we will observe in case of non-rack plus in case of rack? And we'll also see tracing in different levels with the different events. And maybe you are upgrading from lower to higher version, how the performance gets impacted. Parallel query, table partition, index partition, identifying the right column to perform the index creation. Why index creation is important, or what column we should not go ahead and create an index, and types of index creation like a B-tree, bitmap, what is the difference, when to use which one, followed by materialized view and materialized view log. What is the benefit of materialized view and how it will be used along with the materialized view log, and table partition, if I use it, then how the execution plan will looks like, and also the definitely the OS comments. So these are the topics which I need to cover. If you still have any questions, feel free to ask. This is my contact details. This is my WhatsApp number as well. You can reach out to me anytime. Any questions? Common questions? This training will be purely as I mentioned earlier also in the demo, but today also I'm keep referring. The recording will not be given. Rather, you have a one-time registration. You can do one-time payment, or one time you can provide the fees, but you can attend as many times. The same course you can attend as many times, but do not expect the recording, and it is not permitted. I will be sharing you the notes which you can easily read it, and you can also do practice on your own side. Any questions? Feel free to ask. Now here I just covered the topics what will be meant. You can say keep going ahead in this entire course. Now we will be actually starting with this particular machine, which I will be explaining about how to prepare a machine to practice in your own laptop or desktop. So I'll be just minimizing unnecessary the virtual machines. Let me start this particular performance tuning machine. So this machine is pre-installed with the operating system called Oracle Linux. Later, you will be installing your database software. You will be creating one database, which is a CDB. Inside that, we will be creating PDB, and inside that PDB, we will be trying to understand about further explanation, or how do you start begin with your performance part. Let me minimize and start with giving you some basics part. From the architecture point of view, we will try to discuss the few things. So make sure that the terms would be keep, you can say maybe new, or maybe it is already familiar, but you wanted to understand thoroughly. That's the reason you are here, to understand those points. I'm giving you here example would be, I may use the keyword servo buses, background buses, single block, multi-block, auto trace, or maybe buffer gates, direct reads. There are not many things which you expect many more points to be covered. In a given example, you may need to remember, wherever you have any questions, feel free to ask as many times, and make sure that you can uh, get the question as much as possible. If you're not sure, you can keep asking the questions as much as possible. Here is the architecture point of view. We will understand few more points. Let's say example. You heard about in the architecture SQL processing phases. In short, whenever you write a query in my database, what it does it will go ahead and pass these many phases. The phase name called pass, the phase name called bind, and then execute, and followed by the fetch. Now where this pass, bind, execute, fetch will happen, we will have to discuss the same. So we will be covering those points one by one. Maybe you have to wait for a while. I'll just give you the whole details. Now here, let's take example about the architecture. So example here, I given you the server architecture. In this, these are the memory structure. These are your background processes, and these are your physical files. Now, the point which just mentioned here is you wanted to perform parse. So where exactly it is happening? Obviously, the answer is supposed to be in this particular area. What is that area called? Shade. In the shade pool, your parse gets completed. The parsing can be many more points. You can keep checks. Those points we will be discussing one by one. Which process does this parse checking? Obviously, the server process. The server process in my instance, inside the instance, the SGE, inside the SGE, the shade pool. So inside the shade pool, the server process go ahead and check the parse part. What it does it in the parse, it will go ahead and perform the syntax checks, semantic checks, all those stuff checks will be happening. So we will be discussing those points as example. Now here we will be discussing this as well. Let me just explain it here. Your architecture point of view, you should tell your user process will connect to my listener initially. The listener will later contact to my instance. And the instance behalf, there is a server process get started. And the server process go ahead and check in the SGA. That's what I given here. The server process go ahead and check inside my instance in the SGA, the area called shape. What it does it will go ahead and check in the data dictionary about your username, password, whatever you given while connecting, SQL plus username and password, and connection details. So the username and password checking is other word is called authentication checks is happening. Plus, it also checks the privilege, whether you have a privileges with the create session. If yes, this all are okay, then it will allocate the PGA, then the communication gets started. This is what the very beginning you should know how the connection gets established. So this connection or session get established is other word. Your client now started communicating to my instance or my server. Let's take, we will try to now, let me close the previous topics, terminals, and minimize it. And let's connect to my machine. Here we go, PT, and let's connect to my user port Oracle. And let me just start my instance. So this is my syntax which I had written in this particular file. Starting my listener and starting my connecting to my SQL Plus and starting my instance. Just write start with the help of start.sh. Let it complete. Give me a minute. So here, once you connected to your SQL Plus, it says that your instance is not started. The other word is called idle instance. What it says here, let me just give you the points. What I'm just trying to say. It says that here your instance is not started. It is called idle. So once you say startup, it will go ahead and start my instance. Once it says that instance started, it will allocate the SG, and once the background process keep connecting, it also allocates the PGA. It also starts the background processes. And in SG, you have to now note of it. What are the components of SG? So as per this section, let me just open one more time. Here. So this section says that we have one is shared pool. We do also have a read log buffer and database buffer cache. So like this, you can go ahead and see there are many more, but right now the user will, what he does it, he will contact to my which process? The user process will contact to my server process. So inside my instance, we do have a lot of component. So that's we will be discussing now later. Now let's try to go ahead and understand here. Now here, let's go for login to my, which is my alias. I'll call it as here A1. I'll use the A1 to connect to my instance with the username called ambassador, and I'm connecting to my one of the pluggable database called PDB1. So here I will be now connecting. Just see here, my username is and my container name. My username is ambassador and my container name is .pdb. And also I can just check I have this particular scripts folder. So because I just mentioned that initially I will be using the scripts folder to CD. Later I do perform the SQL plus. So this way I just connect it to my instance. Now let's start with giving you initial sentence. But type something with select star from and table name. An example, scott.db. I know here I missed my from option. That means it is checking my syntax. If the syntax is not as expected, it will use a message saying that correction is required. So this is what we call syntactic checks. So if I go with here, asking about initially what happens. Whenever you write any statement, what it does it in the background, it will ask for first syntax checks. Other word, syntactic checks. And if that is not correct, it will not proceed further. You have to mention whenever you trying to understand the performance part, in that SQL processing phases, in that the parse is the first point, which will be checked in the shade pool. So here, what you have to tell? You have to tell here, within my instance, we have a SGA. Inside the SGA, we have a shade. In the shade pool, the syntax checks, semantic checks, and all those stuff is happening. Here, we have a data dictionary. You have to tell data dictionary cache. Obviously, we do also have library cache. So there are two components within the shade or two sections. The process called the row process. We'll go ahead and verify here whether this statement is already exist or do we have that particular table exist. An example here, it says that once your syntax is okay, it go ahead and check the semantic checks. What it means, it will go ahead and check my privilege, the object existence, and followed by the dependencies. The dependencies are the word where it will go for checking. Do you have index? Do you have a constraint? Do you have triggers, procedures, so on and so forth? Along with that, it will verify, do you have a profile, you have a baseline, so on and so forth. If there exist, it will take actions accordingly. If it is not exist, then he will take actions in a different way. So hence, we need to understand while preparing the next action. In other words, he will build the execution plan based on the dependency available or not. The way of the query written. Is this the query has a where clause? Is it a single table? Is it a joins? Is it a subquery? Is it a group by? So on and so forth. Let's keep checking. And if they are single table or it can be a where clause, without where clause, maybe you are asking for multiple columns, so on and so forth. So according to that, he has to decide the plan. So what he does it will first check the syntax, then he will check the semantics. The semantics word says that your privilege, object existence, and the dependencies, and so on and so forth. If once it is checked is fine, then he will go and check in the shade pool in the library cache, checking whether your statement is present or not. Your execution plan is present or not. If they are already present, it will reuse the execution plan. And if they are not present, it will build the execution plan. Who does that building the plan? The optimizer. So let's now try to just check few examples here. What I said, you will be now trying to understand about if someone write a query, select star from Scott.dbt. If I write a query, this query gets stored in this area. What you have to tell? Shade pool in that library cache. So in the background, it is storing in this particular area. So what we call for this, these are all called views. So these views are sometimes called dynamic performance views. You have to tell dynamic performance. Why it is called a dynamic? Because runtime it's keep changing. Performance, it's related to performance, and views is not a table, rather these are the views. So what are the base table for this? It is called fixed objects. You have to tell fixed objects are tables. Whereas on top of the fixed objects, you have a views. What are those views called? Dynamic performance. They are called views. So the fixed objects naming convention would be X dollar, whereas the views would be V dollar. Your total, it's a V dollar. So X dollars are fixed objects where it will be consumed the space in this area, something called fixed area. During your startup of your instance, maybe you have observed here there is something called fixed size. So this area is what it's stored in the fixed objects. So that's the area where you have to tell is within the SGA, the fixed size is for your fixed objects where it will be maintained your instance related information. During your instance gets started, this gets created. Once you stop your instance, this gets dropped automatically. So now we will try to understand. In case of if I type SQL text and we will check, did you check called passwords? Did you completed in the shared pool the statements? You can verify it. You can use this particular option SQL text parse calls and something called here executions. So we have to remember there is something called hard parse. So this is like how many times you checked in the shared pool. It's called total parse, and in that how many times you did a hard parse and how many times you completed your execution. This is what we are checking in the view called SQL, where your SQL text can be anything, but just in our example, we will be taking this as an example. So let's start from Scott.delete and let's put here where condition. So output is not showing me anything because I haven't executed any signal. But let's try to write the same option like select star from Scott.delete. Once I hit enter, now I can verify the same statement has been executed. What it says here, it is saying that here we have a one pass. Now let's repeat once again what you have to note of it in this particular section. What I'm trying to now cover one by one. This is my example SGA. This is my SGA. You have to tell what this SGA says that it's a shared global area. Inside the shared global area, we have something called shared. Now remember, there's something called shared. Now inside the shared pool, we have a two components. One is called data dictionary cache and one more is called library cache. Okay, so that's what I need to remember. Something called one is my data dictionary cache, two is my library cache. Theoretically, we have to tell it's a shared, your shared pool as a library cache, but practically you have to tell this is my area where we call it as library cache. So what it does, it will verify here. Do you have a statement already? If yes, if no or yes, that depends. Is it the first time you are writing a query? If it is first time you are writing a query, then it says that no result. That's what it says here. So what you have to tell? You have to tell here something called maybe it is present first time. If it is a maybe it is a no more exists. Let's go for one more time. Yeah. Now what I said here, maybe it is not there at the first time. If it is not there at the first time, then it is what we call it here. It is not there, then you have to load it. You have to store it. So first time it is verified. If it is not there, then load it. Sometimes it is called, you can call it as the build the bar or hard pass. You have to tell it's called hard pass. And you complete your execution. So this area called pass, this area called execution. Now here, what we actually completed, we completed about pass part, we completed execute part. Now here, this is just the beginning where we will be learning many more things. But I'm just giving here. What is this column called? It is supposed to tell parts. What is the view name? View name you have to tell in video. Now here, if I tell this count will be later maybe 2, 3, 4, but this count would be as is 1 only. That means 4 time pass done, but 1 time hard pass done. You have to minus the 4 minus 1. You have to tell 3 times soft pass is completed. Let me just show you with practical again. Let's go for here. What I said here, let me just rerun the statement. Second time, third time, fourth time. So I completed 4 times now. I can ask now how many times we did a passing now. What it says here, it says purely says here it says you checked 4 times and you did only first time hard pass. That means your 4 minus 1 equal to 3. That means 3 times you did a soft pass. Okay? It's called soft pass. Now, what do you mean by soft pass? Soft pass is nothing but reuse existing existing execution. So what we have to tell? Soft pass is nothing but reuse existing execution plan. Who does this decision making? Obviously, that engine name called Optimus. And we have to tell the optimizer will decide whether to go with one more time hard pass or he has to reuse the. Now that's a number, just make a note. And if I now try to take different statement, so let's remove this. And let's try to understand one more time here. Each statement will have certain extra column called SQLite and hash file. Remember, this is one more point to note. What I said here, your statement, the statement says that I write a query, backend, Oracle will convert this given query to ASCII and ASCII to hash value. So this is what the hash value, what you have to remember. Your query internally converting ASCII later becomes hash value plus SQLite. And this SQLite concept started from version 10G. Up to 9i, we do not have SQLite. From version 10, now when we have 23 AI, we crossed many versions. Still, basics points supposed to remember. So up to 9i, we don't have this concept SQLite. We used to only tell based on hash value. But now from version 10G onwards, or nowadays we do not see 10G, 11G, even 12C. So we even 18C. So after 8i, 9i, 10G, 11G, 12C, 18C, 19C. Now we have a AI. Okay, so 2 I's, 2 G's, 3 C's, and now N. So this is how we crossed. Now I said this concept started from SQLite concept from 10G version. Okay, so let it be. And let's provide for continuation. Now what I said here, I need to remember about this is my hard pass. And this is my total passes. The same thing you will see in your AWR also. You can open your AWR. AWR stand for automatic and workload repository.
Sir, so I mean, parse calls and executions will be always same.
Parts and execute may be same, may not be same. So the expected question here is this always they both are same? No. They may be same, they may not be same. So here you have to remember, is it when it will be same and when it will not be same? That's the next point. And if it's same, what we call for that. And if it is not same, what we call for that, we will discuss for. The short form of the automatic workload repository, we call it call. Now, question asked here is, if I do tell 4 time pass, 4 time execute, but in that 1 time hard pass. So how many times you did a soft pass? 3 times. But if I tell 1 time pass, 1 time hard pass, but 4 time execute, what we call for that? You have to tell it is called softer soft pass. Softer, soft, and pass. So you may heard about soft pass and hard pass. What is that? You may heard about maybe soft pass or hard pass, but you may not heard about soft pass. When you say it's a soft pass, 1 time pass, many times. I'll show you with practical about what is the case it will perform 1 time pass and many times execute. So which is the best option? If I ask you, tell me which is the best option or what is the bad one. Example, I may say here, example, 4 time pass, 4 time hard pass, and 4 time execute. So what we have to tell? 4 time pass and 4 time hard pass and 4 time execute is actually supposed to call it as. So if I tell you 4 time pass, 1 time hard pass, 4 time execute, it is good. And 1 time pass, 1 time hard pass, many time execute. This is very good. Why it is not very good? Because it is unnecessary, not wasting time for checking your pass. Is it possible? Yes, it is possible. When it is possible and how I need to understand what situation it does this way, we'll see that. Which is bad because of every time doing hard pass is bad. And it is for bad. You reduce this value and it is for good. You reduce this value also and it is that's the result. It's for well. So keep reducing is the what it is it always happens in a real time with all the bad the hard passes every time? Maybe that depends on how application has given the statements. So hence the conclusion would be so which is good, which is bad, which is already given here, and you have to note accordingly. Any questions here? Any doubts to ask?
Uh, are these available in notes also, sir?
Yes, I will be sharing this all in the notes as well. Answer yes.
Okay. Yeah, thank you.
So what is the third option? One time pause and many time execution, many time, one time hard pause.
Okay, let me just give it to you. So what we call for this. Let me take this syntax and write it down in the notepad. Okay. So here, let me write it. So here, what we supposed to call. So here, case 1, what I said, parse calls, and this is a sometime called loads, sometime called hard parse. And if you minus your parse calls with the hard loads, you'll get a soft parse. You have to tell parse calls minus loads becomes your soft parse. And I have to tell the executions. So if I give you case 1, 4 time pass, 4 time hard pass, and soft pass is a 0 because 4 minus, you can say it's a parse calls is a 4 and hard pass also 4. That's for loads is 4. So 4 minus 4 becomes 0. Soft pass is other word, it's a 0, and execution will be 4 times. This is the what we call the case 1. In this case, the load is the other word, the hard pass. Now let's try to take a next case, case 2. In this example, what we said, we reduce the hard pass. We said that, okay, we have a 4-time parse calls, but 1-time hard pass, and 4 minus 1 becomes a 3. 3 times soft pass. This is also one way it's good. But if I take the third case, which I supposed to say, 4-time instead of that, 1-time pass, 1-time hard pass, and here soft pass would be initially it's a 0 itself, but because of the 1-time passing, 1-time hard passing, many times exit. So this is absolutely good. So this is what I need to explain. What are the situations you may face or you may expect in the real? These are the 3 cases which I mentioned. Case number 1, I given you what is the case here mentioned. This is what I just mentioned. One is a 4-time pass, 4-time hard pass, and 0-time soft pass, and 4-time execute. This is called always hard pass and always checking the pass. So this is what sometimes maybe not the good options. The second which I mentioned here is reduce the hard pass, but still not reduce your soft, just checking the pass. So, but you may say that it's a soft pass, but still passing is not reduced. This is good option. And finally, we said that only 1-time pass is also reduced, hard pass also reduced, and execution is more. This is very good. So this is how maybe this is only works when you have a PLSQL option, not for the SQL. These two are maybe you have a SQL or PLSQL, doesn't matter, but this last one is required. A PLSQL has to be written. Without PLSQL, the third option will not be possible. That's what we will be discussing later. Let me just check what is the question. Difference between pass, call, and executions. Okay, that's now the question has to be discussed or to be decided or to be further need to understand. Let's try to understand about the question asked and also we will see the difference here. I'll go ahead and open this particular document. This all document will be shared to you guys, don't worry. And try to see how many types of the pass these SQL phases. What I said here, we have a SQL statement. We call here it's a pass and it is called execute. So do we have a bind variable? If maybe or may not be. If you are not using bind variable, then this is the option. And if you are using bind variable, then this phase will be concept picture. So you have to remember there is a pass, there is a bind, there is a execute, and there is a fetch. So the fetch also will happen when you go with the select. If you don't do a select, then fetch will not be it is not happening. So we will again have to discuss on that how it works. Let's take here this is an example. Let's scroll up. So what we are discussing is SQL statement for phases. So what internally it is supposed to perform? It has to check syntactic checks here. It does syntactic checks. Is it the statement is okay or is there any statement problem? If that is fine, then we'll go for semantic checks. The semantic check says that do you have a table exist? Do you have a privilege? Do you have you can say the dependencies? These all checks is what we got semantic checks and privilege checks.
Sir, syntax check will be done in shared pool.
Yeah, it is the engine will be done in the shared pool itself because he has the engine. So that's a engine will be verified. Syntax plus semantics checks will be done. This all passing will be checked in the shared pool. Answer your question.
Okay.
So where's the pass will be happening? The question expected here is a pass.
Sir, and in which part? I mean, in shared pool, in which part? I mean, library.
Initially, this is in the data dictionary. So when I talk about here, we have two sections in the data dictionary cache and library cache. So library cache where your statement gets stored and your syntactic checks and semantic checks will be happening in your shared pool data dictionary cache. The data dictionary has that all information about where you have supposed to verify the code cell. So answer to that in the
Okay.
shade called data dictionary cache.
Okay, thank you.
Now the next point we have to remember here is I have to explain in this case. Why we need optimizer? Because he has to decide whether it's a good plan or bad plan and all that stuff. So how do I say it's a good plan, bad plan? We will have to discuss, but I'm now trying to just cover here. The statement name for here. This is the one which I need to now here. The point to know there is an optimizer. This is an optimizer. So optimizer is an engine. So the engine has further three internal division. What is that optimizer says? Optimizer says initially I will try query transformation. If it is not really required, he will ignore this. What is it query transformation? Maybe you have written some query. Query within query, we call subquery. The subquery will be converted as the joins. It internet does this. We don't need to tell anything. Who does that? Optimizer. So optimizer converting subquery as a join internally, that is what we are supposed to call query transformation. And is it mandatory? Obviously, it is not mandatory. It is just a try to do that better way. If the subquery is not working as expected, it will work as a joins. Possible. So this is what we call query transformation. Same way, we have to remember later, before deciding the execution plan, you have to check its statistics information. Where it has to check? Again, the data dictionary. So what is the data dictionary? Like DBA underscore tab score statistics. This is for table. So maybe you have to remember DBA underscore table. This is one more view. DBA underscore tables. What we are checking here? Statistics. Before going for plan generation. So the query plan will be generated after query transformation, after statistics checking. Again, the question is expected. Is this stats are mandatory? Again, it is optional. It is not mandatory. Statistics, if it is not present, we will go for runtime collecting statistics. Maybe it is present in my dictionary, may not be present in my dictionary. If it is not available here, then it will go for dynamic statistics or dynamic set. Let's see, this is a bit practical part. In a minute, let me show you. Here you go. Let's now try to show you how the term says. What is the question asked? Let me check. Question. Why query needs a multiple hard passes? Okay, the query required multiple hard passes because of the existing plan may be invalidated. The current plan may not be suitable, or somebody performed some DDL, somebody performed some structure change. In that case, the existing plan will not allow by the optimizer to reuse it. In that case, it's mandatory to go for build the plan again. For that reason, it may go for hard pass. Does it always require to build hard pass? Maybe, may not be. That means it's not necessary that it always go for hard pass. When it will go for hard pass, when it will not go for hard pass, yeah, that is somehow you need to properly understand. That's what we will be seeing in the actual further demonstration, where I will explain you. Yeah, this is the case where it does the one more time hard pass. This is the case where it may reuse the existing plan. Let's now move on to our next discussion. So here what I said, I may try to give utility name for set auto. So here the utility called set auto trace. Inside this explanation, I will tell you if the statistics is present, how the plan looks like. If the statistics is not present, how the plan looks like. Plus, you should also know what you mean by statistics. That also we will see. Let's try to go for example. I can write set auto t trace exp. I will give you further explanation on how to use this auto trace option. Currently, today we will just understand. I'm using this particular short form and try to write the query. Select star from squad.delete. So in the bottom section, does it show you any line of the node? Answer no. That means it is using my statistics. Let me just try to delete the statistics. Example, execute dbms underscore stats is my package name dot delete, rather say gather as a delete underscore table underscore stats. Within the bracket, I'll put my owner name and I'll put the objective. So here is my objective. What I did, I deleted my statistics. Now, even after delete, does it checks the existing statistics? Obviously, no. The once you say the delete, obviously we do not have statistics. So in the bottom section, in the node section, you will come to know that it is going for dynamic statistics, runtime collecting statistics. Why it is going for a runtime collecting statistics? Because we have deleted it. Now, where it is deleted and how it is deleted, let's show you practical. See. So let me just explain you. How do you say statistics is deleted or not? The one way which I can refer, it is going for runtime collecting statistics by using this particular node section. Node says that dynamic statistics has been used. The some confusion, sometimes it is called beginning statistics, dynamic statistics, the later it is called dynamic sampling. So it's sometimes called dynamic sampling, sometimes we call dynamic statistics. Parameter name point of view, it is dynamic sampling. From the concept point of view, nowadays we have to call it as dynamic statistics. Beginning it is called dynamic sampling. Nowadays it has to call it as dynamic statistics. Let's continue with the next point. Here, let's try to make it of this option. Now, let me just show you. Give me the table name. Give me the blocks, but you have number of blocks in this particular table and number of rows in this particular table. Now, which view DBA tables where my table name supposed to be the DPT. And I may tell, okay, and the owner supposed to be, say here, Scott. What it says, it is a blank. If these columns are blank, it's supposed to call no statistics. Statistics is not present. Now let's try to go for writing the gather command. Now earlier I did delete word. Let's now go for gather. Here I have to say gather. So what is the gather does it? It will update here. So example, now here spelling mistake, sorry. Here you have to tell gather stats. Now once you update the gather stats, now what to check that is this columns are updated? Obviously say yes. Now if I go ahead and now delete these stats again, here you go, and go ahead and check now this columns are becomes a blank. So the gather will update the views and delete will remove the entry from the views. Now not only these options, maybe an example, I may go for here few more columns. So what it says that this is the called average row length. Now what exactly its meaning, let me explain here one by one. I tell you what is maybe the question expected. In this view, we are checking column name called box, number of rows, average row length. Collecting this information in this view is called statistics gather. Now let's take example here. I have this particular table. Table is made up of extents. So what I need to tell is my table. The table is made up of what you have to tell? It's an extents. And the extent is made up of blocks. You have to tell this my extent, and extents are made up of blocks. Now within the blocks, what we have? We have a row. So we can call it as row 1, row 2, like that. So what we are saying that inside the blocks we have a rows. Now the block size is 8 KB. My exchange size is 64 KB. An example. What would be my table size? If I give you one exchange with 64 KB, another exchange with 64 KB, like that, I may give you 64 KB exchange anymore. So the point here is keep adding this exchange value. Nothing but your table gets keep increasing. It's because segment gets increased. Now here, this is what it is record. There is a point to note of it here. What I'm supposed to tell? There's a table which is made up of extents. The extent is made up of blocks and the block is made up of rows. So now we need to tell how many blocks we have, how many rows we have, and what is my average row length. In fact, a block, maybe one row has 1 KB, another row maybe has a 2 KB, another row has a 3 KB, and example. So total, if I take 1 KB, 2 KB, 3 KB, if you plus it and divide it, you will get an average. So 1 plus 2 plus 3, overall 6 KB. And I have a 3 records, that's divided by 3. Let's say on an average, the 2 KB. That's my average row length. What is the average row length? You have to say it's 2 KB. This is how it is calculated. Why should I calculate this on? To decide my plan. The execution plan, to decide it, it needs this particular information. So now here, statistics related to table, we call number of blocks, average number of rows, average row length is what it is required. And to go with the other points, maybe with respect to index, with respect to the column, we have additional information to be added. That's what we call gather stats. Now here, where it is checking, this is checking in case of this particular option. Now let's take an example here. What it says here, in this case, we are looking for, in case of the optimizer says that, so supposed to say optimizer, query optimizer. So what it does, it will first check, does it transformation required? Maybe may not be. If not required, let it be. Then you'll go for stat checking. Estimator, we call estimator. Estimator, it's internal checking statistics. And that's what I have told you. If the blocks column or number rows column, if the average row length column, if they are blank, null value, other what? Statistics is not present. Then runtime correct statistics, sometimes called dynamic statistics or sometimes called dynamic sampling. Followed by will build the plan. Now here is the important question. Query plus estimates, that's later becomes a building the plan. Now the query execution or the building execution plan is what you need to remember. Now here it will decide which blocks to access. That is we called execution. So you asked the question about what is the difference between parse calls and executions. So after you decide how do I reach an example, say here. Now let's take example. I have a particular table. Table is made up of, let's say, hundreds of blocks. Now it's a very simple question. If I have a table, just an example purpose, I just demonstrated or just written saying that we have hundreds of blocks. So block 1, 2, 3, and so forth. Let's say hundreds of blocks. Now inside this hundreds of blocks, you asked, give me the records, select from all the column from the table, and let's say sort of the, and here, or maybe you can say instead of a DPT, let me just take here. I will say here, instead of DPT, I'll say here. And I'm just writing where plus, where employee number is equal to 1. What I'm just trying to learn here, I'm trying to say in this case, I'm asking for read this particular table. In short, I said, go ahead and scan this entire thing. But conditions apply. I need only this record. Now, what it says, it will read all the blocks and then it will say that, okay, your record, employee number 1 may be present here. But what we did here, we did a unnecessary read 99 blocks extra. What your actual data present employee number 1 presented only here, but you are bringing unnecessary this extra block. So this is the problem. So what we decided, we created here in this column index. Then what index does, it will index will maintain information about your block or the row. So let's say example, your index says that my employee number 1 is presenting, we call it as row ID. The row ID will tell you that my employee number 1, which is presenting in this particular row or in this particular block. So the row ID stands with file number. We have to tell file number, block number, and object number, and your row number. So that means it's a combination of these four values. These are the words called row ID. So instead of scanning these hundreds of blocks and then giving only one record, so this row ID will give you, okay, your block number, you are asking row number, that is present only in this first block or maybe in the fifth block. Don't bring another blocks. What we performed here, unnecessary scanning gets reduced with the help of my index. The index is that why should I bring unnecessary blocks? I will note my position of the block inside that row. I will bring only that particular block. Expected question, what is my IO unit? The IO unit is your block. So my table has a sometimes called segment. The segment is made up, it is present inside my data file. The data file, let's say example, it's a 30 GB. My table size is, let's say example, 1 GB. My table size 1 GB, but I need only one row. Then, does my table or my server process will bring entire 30 GB or does it bring entire the segment? Let's say example, it's 1 GB, right? So I'll say here 1 GB. Does it bring 1 GB or my extent is made for 64 KB? Does it bring 64 KB or does it bring your block 8 KB? So answer to the question, IO unit is block. Hence, your expected answer is supposed to be but the entire file will not be taken into the memory. Entire table will not be taken into the memory. It is taken but by block wise. So how the block will be taken? Either single block at a time or up to 128 block at a time. So 128 blocks is the what? If I said 8 KB is my block size, if I multiply by 128 blocks at a time, it becomes 1024 blocks. Sorry, KB. So how many blocks at a time? 128 blocks. Each block size is 8 KB. So 8 KB multiplied by 128 blocks becomes 1024 KB. Other word, 1 MB. In short, your table can be as many bigger, doesn't matter. Your IO will be bringing either 8 KB at a time or 1 MB at a time. So due to that, the interview question may be expected, but table size is 1 GB. Example, this is my table example. My area called DB cache. Whatever DB cache size example here, let's say 500 MB. Can it possible 500 MB? Not. Here you go. Let me just take it's here 500 example. So what I said, my DB cache size is 500 MB. Table size is 1 GB. But can it possible to fit 1 GB data in 500 MB? Obviously no. But does not mean I'm bringing at a time all. I will bring 1 MB at it. Maximum. Either I will take 8 KB or either I will bring 1 MB. So hence it will be taking 1 MB, later get flushed, again bring it 1 MB. Like that, you can see that it will be keep following LRU algorithm, which recently you started. So hence you need to tell, no need to worry, even though the memory is small, your file or your table size is very big, doesn't matter, it will not give any error, rather it will give 1 MB at a time, so hence it is possible. So what is the conclusion here? So conclusion here is, so where you are bringing the blocks, you are bringing the blocks into the memory. So that is memory called GA, and or you bring the actual data directly to a PG. So that's the answer supposed to tell. Either you give the blocks to the AGA or directly to PGA. From where? From your data file. Example, this is my data file. So from the data file, you give it to AGA, and from AGA to give it to PGA, or directly give it to AGA. Sorry, PGA. So what we call for this? Giving from data file called physical read. Taking from LGA called logical read, and giving from here to data file to PGA direct read. This three is what is called execution. Initially you read it parts. Now we are discussing about execute. What I call it as one physical read. Short form sometime called disk reads. The column name called disk reads. In the VWM SQL. Second one, logical read. And what is logical read called? It's other word. Buffer gets. Column name called buffer gets in VWM SQL. Third one is called direct reads. Column name also the same. Direct reads underscore read, you can say. So what is the first one? Taking from this file, it's called physical read. And from here, you have to give it to here. From SGA, you are reading it is called logical read. In the SGA DB cache.
Hello.
What you are taking in the
Hello.
data file, obviously not data file you are taking, rather you are taking block wise. Don't say you are taking the file. You should tell you are taking from the data file blocks wise. From the block from the file you are taking the blocks, part of your table, obviously the second. So the blocks you are taking to the SGA or physical read. Now what we have to understand from the performance point of view. Performance point of view, if I bring 100 blocks and then I'm reading in this 100, I am keeping in the DB cache 100 blocks, but my data only present in this first row or first block, then what is the problem? Unnecessary 99 blocks extra reading. This is what you have to tune it. Don't tune this extra block bringing, is other what you are wasting your time. Wasting what exactly you will be wasting? One is time. Second, to bring it, you need a IO. That's like hard disk IO. Once you keep it in the memory, you need to burn the CPU to read the data. To keep the data, I need a memory. So now you need to calculate what all you are doing unnecessary, extra work. Your IO, you are doing extra work. Your CPU burning unnecessary. Your memory requirement unnecessary. Obviously, you need a more time. So this is what we call unnecessary work. And this is what you have to tune it. If you don't tune it, then there will be a problem. It's not just one, there are a lot many. So like this, we will be keep discussing on further points. This is just one example I said. Now what we actually learning, the terminology called physical read, logical read, or direct read is the other word is called execution. The previously we discussed about soft pass or hard pass or soft pass. It's called pass. Either you call parse, that can be soft parse, hard parse, or soft to soft parse. One is called execute. The execute can be physical read followed by logical read, or it can be direct read based on what kind of a request you are performing. So that's how you need to mention in your given SQL processing phases. Any questions here? So what we have to decide, let's go for here practically.
Yeah, I
Right,
have
that-
a question.
Yes, please go ahead.
So every time a user reads data, it has to come through PGA only, right? There is no direct from SGA to end user.
Okay, the question is expected here. Let's say go for this question. What is being asked and how the answer is supposed to be. This is what the question is asked. Okay, so here you tell in this case an example. You are giving from the data file, and from the data file you are passing to which area you are to give it to my. From the file you are giving to the DB cache. You are giving to DB cache, or you are directly giving to PG. Or if it is already given to DB cache, you can take it from DB cache to FPGA. At the end, from here, you will be giving to my user. And again, who will give it? Obviously, this will be first taken by the process we call here. Here, what we call it as? We call it as here. The server process will read this information and later hand over to user. So this is what we call user process. Now your question is it always give it from the, yeah, what is your question? Please go ahead one more time.
Yeah, I mean, why always through PGA? Why can't it from SGA?
Okay, why can't it give it directly SGA? Because
Yes.
it's a shared one. Answer to the question. It is the common area for all sessions. And this is for individual session. The individual session will be deal with your own server. That's the reason your things will be given not directly SGA to user, rather things will be given from SGA to PGA. The one more important point, in the PGA you will be taking in the row wise. At the end you will see what we call for that kernel. Stand for current set of records. Current set of records. In short, you will be getting specific record, specific column based on how the query has been given. So that will be given into the PGA. But in case of DB cache, you will be taking as a block wise. That's another important differences. Here the diagram also says here, if you're taking from the data file to my PGA, sorry, to the SGA, either you take one block at a time or you take multiple blocks at a time. It's possible. If you take one block at a time, you are asking to wait, you will get the sequential read wait. You are taking multiple block at a time. You are asking to wait, you will get scattered wait. And if you are taking either single block or multiple block, doesn't matter, but you are taking directly from the data file or writing to the data file or reading from the temp file or giving back to the temp file, we call direct read. Either called direct path read or direct temp path read or direct path write or direct temp path write. These are my variable names. Hope it's clear. Any question?
Sir, in this scenario, he will directly write to the PGA.
In this case, what is the question?
In which scenario the PGA, so data file, so PGA directly read from the data file.
Yeah, these are the answer for that question. So what are the points? One is CTAS case. If you go for rebuild or move table, if you are trying to write it to a temporary table, if it's a parallel query, if it is LOB segments, and if it is a EXPDP, RMPDP or SQL loader, those are the cases where you go with a direct path. Is that clear?
Okay, thank you, sir.
Thank you.
Same thing. The follow-up question is like, in what scenario user gets like PL SQL procedure is the gets from data directly from SGA? So individual users gets data from PGA.
No, user will get it direct data always from the PG. So
Right.
either you take it from the data file to SGA and then to PG, obviously to the user, or
Okay.
data file to PG and then to user. So you are mandatory to visit PG.
So no matter what, it has to come through PG only.
Correct. Answer to that.
Either individual
Yes.
query or individual user or any. Okay.
Yeah.
Thank you.
Thank you.
So can you please explain the direct path read one more time?
That means it is directly taking, skipping the SGA. You're directly giving from the file to PG. It's for direct. So from the file, that file can be data file or temp file. You are giving your data to my PG. That is we call direct. Whereas if you're giving to first SGA, it is called from physical. Later that has to be I can give it to from PG, SGA to PG. So that's what the diagram says here. Any question? So this is an example. Can you see this is an example here? So I'm taking from the data file. You are taking here to my DB cache, and then from the DB cache you're giving to my PG. It is called, if you take it from here, it is called logical read. And if you give it from here, it is called physical read. And if you directly write it here, directly write it or directly read it, it's up to you. It's we call direct read or direct write based on audio process. This is we call PGA and this is we call DB cache of your SG.
So, what is the sequence scatter read?
That's a weight. If you are asking weight, that weight name of the weight is called weight event. So
Yeah,
now
but-
let's say example, you trying to read the data, but hard disk asks to wait. That weight will be calculated, name called weight event. Let me explain it here. Example, you said I wanted to take the data. From where you wanted to take the data? From this file. What is the file name called? Data file. So you wanted to take from the data file into my SGA. You wanted to take the data from the data file to my SGA. So there are two scenarios. You take one block at a time, or you need to take multiple blocks at a time. So based on what it says, you can refer here. Either you take one block at a time or maybe multiple block at a time. So asking for a weight, it's over here. This is my first block, one block at a time, and this is a multiple block at a time. Depends on one block or multiple block, the sequential keyword and standard keyword. So what we said, wait. Why should I wait? Because of IO will be given to you before step for first in first out. First in first out order case where it is asking you to wait. When you try to take the block and asking to wait, that wait will be calculated. The name of that wait is for sequential read. And since it is a data file, hence it is called DB file sequential read. It can be a control file sequential read, it can be the other file sequential read, but here right now we are discussing on data file. That's we called sequential read, sequential keyword, one block at a time. And why we give this name? Because they want to calculate how long you are waiting. Now the next question, what is the accepted wait? So that you have to tell accepted wait is supposed to be less than 20 milliseconds. If you are taking more than 20 milliseconds, then your hard disk is slow. You have to replace your hard disk or ask the system admin to change the hardware. Or once you bring the new hard disk, then you have to move your file or table into the new location. Any question?
So repeat again this.
If you are trying to take from the hard disk to my memory, if that timing is more than 20 milliseconds, right now I said it should be less than 20 milliseconds. But if it's crossing more than 20 milliseconds, it is taking a lot of time to take the data from hard disk to my memory. And if it is taking the time, then it is a indication that your hard disk gets slowed down and you have to replace it. Yeah, that's what I
Every sequential read should not be more than 20, right, sir?
Correct. This is an average. It is called average and weight in terms of milliseconds.
So where we can find those information in the
It is in your AWS.
Okay.
In your AWS, you get average weight column in your top weight bits. There I will show you how do I refer it. An example. Let me explain it where exactly you have to find. You open your AWS report. Example, I will just sample I have production report. I'll take this in my real production. There, I'll just try to document it. Here, I'll take one of the AWS report. Here. In this report, you have to scroll down and go ahead and check this section. What this section says here, it says in this example, your average is saying that 20 milliseconds. It's a MS. MS are the what? It's a milliseconds. Now what we are actually looking, we said that here it is taking user in nothing but it's taking the hard disk. How much time it is taking? 7. So sequentially it's taking 7 milliseconds. It is accepted. If this value is not more than 20 milliseconds, other word, less than 20 milliseconds, then it's okay. It is not a hard disk problem. Since it is less than 20 milliseconds, that's okay. And your weight loss supposed to be because I what is action in the foreground variables. Foreground are the what? The server process. Server process is a foreground, we call it as. And again, there is a point to note. If it is a top 5, sometimes it is called top 5, sometimes it's called top 10. Up to the version 11.2.4.0. So you have to tell it is a top 5. And from here onwards, we can say here up to 11.2.0.3.0. So you will see here, you see top 5. From this version onwards, you will see top 10. Nowadays we have 23. That's what I say. It's nowadays you will not see the top 5. You can always see top 10. Okay, let me just take 19C stuff, minimize this, and let's open one more AWS report here. And just try to give this report. So this is an example. I can just see here. Wait a minute. So now what you have to tell? Top 10. In this top 10, what we checked here my sequential read and scattered read if it is coming, and if it is user IO. Right now here there is no user IO. Otherwise, you have to refer that. If it is user IO, you have to tell how much is my millisecond. This column you have to write. Any question?
One question. Okay. In what scenario we see higher logical IO and zero or less physical IO?
If I do one time physical read, later if I rerun the same statement again and again, you will see lot of logical reads compared to
We have a data in SGA
in the memory.
only.
Yeah, in the SGA only. An example, let's take here. I already now remove this average stuff. Let's not try to refer this. This is my statement. Let me write down. Give me the SQL text and ask him to provide the disk reads, physical reads, and ask logical reads, and ask direct reads. And which view SQL, where SQL text like your query may be select star from Scott dot here. I have to say here Scott dot db. Example. It says that you can see here it is performed 13 disk reads but 120 buffer reads. zero direct reads. Now here, what I'll do, I'll just try to ask, tell me along with this, how many times you did a parse calls and how many times you did executions. It says that I did a 6 time parse calls and 4 time execute. In that, total buffer gets is completed here. Now try to write even including number of times you did a hard parse. I can just ask, give me the hard parse also. Now, what is the column? It says that the direct reads is nothing, so that's a 0. So how many physical read, how many logical read, and how many hard parse. So don't get confused between, commonly again it's confusion. This will be called hard parse. This will be called physical read. And if I talk about here, this is my logical. People says that confusion would be physical read and the this will be called hard parse and this is my physical read. They always get mixed. They always get confused. So this is happening in my shade. This is the taking from the data file. This is the reading from the DB cache. DB cache. And this is from the directly to PG. So this is you are doing with your blocks data to refer. Here your syntax checks, semantic checks, flag checks is happening. You did this all stuff checking is other word here. It's a executions part. But note here you are doing your executions. So how many times you executed? 4 times. But 4 times you executed this can vary. Let me show you how this vary. Let's
So
see.
here execution happened 4 times, parsing 6 times. How
Let's
it?
say if I rerun the same statement one more time. Give me a minute. Let me just rerun it. I just executed one more time the same query. Now see what happens after this. The query gets re-executed 7 times. It's a parse call. Only 1 time hard parse. Execution count earlier 4 now becomes the 5. Physical read becomes a constant, but logical read gets increased, and it is not a direct read, so it's a still 0.
Sir, if it parse means it should execute, right? Is that correct or wrong?
Doesn't matter that parse can execute it. So sometimes you say that parsing is done, but I do not, you can say, completed my execution. So I did a control C. In that case, may not be guaranteed it may execute it.
Okay, sir, got it.
That's why it got differentiation there.
Yeah, that's the difference.
5. Okay.
And now if I keep running the same statement again and again, so again I execute it. Now go and see that it's a count gets again increased 6, 7 to 8. Again hard parse is the same, no more increased. Execution count gets increased. Physical read is not increased. Logical read increases. Now what happens if I do alter system flush buffer and scope cache? Don't do it in production. So after that, if I go and check, they are still the old count, but let's not try to rerun the query. Now see what happens in this case. Now physical reads gets added extra. Again, logical read gets added extra. So what we did, we just flushed my DB cache and it gets added my physical read. So what you have to tell? Now here we said that earlier. This is what it says. Earlier we have a physical read in this example. You can take the physical read count and also you can verify it here. Any questions? Let me just take a few questions here.
Sir, it increased 6 and discretes and buffer gets 7, right? How it is increased 6?
I did one more time query run.
Means discrete 13, right? Extra.
Yeah, I did a flush.
Okay.
I did a flush due to that. So why it is increased now this time the physical read? Why not earlier? The answer to that question is earlier it is here. Earlier it is not done the DB cache flush, so it is available earlier in the DB cache itself. So that time it was a constant. Now once I flushed from the DB cache, now it has to bring it back. So due to bring it back, it has to go for here, increase this value.
Okay.
It's clear.
Yeah, sir. How can we calculate by seeing the query how much IOs will do? Any
You cannot tell that.
what Oracle decides?
Yeah, Oracle decides based on the size of the your table and also your where clause and the dependencies what you have it. According to that, it will be decided.
Okay.
So you mean to say after pressing the plus buffer cache, it has to go with the again hard parsing, right?
That's what now the question confusion. If you flush the DB cache, then it will go for the physical read. If you flush your shade pool, then it will go with the going for hard pass. So right now we are not flushing the shade pool, so hence it is not changing this value. Is that
Okay,
clear?
can you repeat again, sir? Buffer cache means like what is
Physical
it?
read. If the DB cache is flushed, then this gets increased.
From where it has to read through only the data file, right, sir?
It has to reread it from the data file. Answer yes. Answer yes. Now let's go for here. Alter.
Sir, how many blocks are there in the DB cache? How to check that? That this query has brought what number of blocks in DB cache?
It is again, this is what the column, right? So these many blocks.
These many blocks.
Yeah.
So in the case
These many IO calls or these many blocks?
When I talk about the number of blocks, now your question is expected. The how many times you perform the blocks, that's IO. So IO count would be the, let's say example here. So if I say that this is one block you taken in this place, it's the count gets increased. If you taken one more block, again this count is increased. Okay, so that means you are taking as many blocks from here. This gets keep changing the count.
So in case of multi-block,
If I bring it, let's say if I bring it at a time, the multiple blocks doesn't matter. So this is we got all our disk rates. So we right now cannot say it's a single block read or it's a multiple block read until unless you are not reading from the your AWS report by respect to stats. Is it a sequential read or scattered read? If the sequential read, then that means you have more blocks, you are bringing a single block. And if it is scattered read and you are bringing multiple blocks at a time. Yeah.
okay. So if say 8 blocks at a time, then that count one will be increased in discretes, right?
Yes, answer to that, yes.
Okay, got it.
Now let's continue here. Now if you flush the shade pool, then this value would be no more selected. You can see here, it is no more using this Visual SQL will say that now flush is done. So due to that, no more output. After flushing, if I rerun the same statement again, go ahead and verify. Now the hard parse gets increased. Because of it is earlier one hard parse, now it's one more time hard parse. So it is checked one time, but one more time hard parse is complete. Hence it is called here, it is the cumulative value. Cumulative means previous value will be included. So now how many times you did a hard parse? Previously one time, now the second time. You checked in the sheet, maybe not there.
Sorry, discretes will cost more if we get more discretes and cost more for query, right?
If it is performing more discretes, that means it is maybe slow down, or maybe you are keep hard disk reading. That means it may not guarantee that it is slow down, but it says that if it is less than 20 milliseconds, that's acceptable. But if you bring it unnecessary block, then it's a bad. If your taking time is less than 20 milliseconds, it's still fine. You take it from the disk reads, that's okay. It's taking less than 20 milliseconds. But if you bring
logical reads are increasing, that is not an issue.
No. Answer that also not correct. Now, if this is increasing it and this is a fixed, that means you are reading from the memory is okay. But reading from the memory also not free. So if I tell every time I'm reading 1 million buffer gets, is it good? Answer that depends. I'm reading logical read 1 million, but I'm giving only 2 records, 2 rows output I'm giving. Why you read 1 million blocks in the logical to give only 2 records? So in this case, it is even the logical read, it is a bad. Is that clear?
Yeah, I got it. Thank you, sir.
So now the question is asked here. Buffer gets is otherwise is a logical read. So is it my logical read if I say that always keep coming, and is it good or bad? So answer, if logical read also coming, let's say today you have taken 1 million from logical read and you are giving only 2 records. That means it is not a good one. So why we read 1 million of blocks to give you only 2 records? This is like a wasting of unnecessary time. So buffer gets even though 1 million, but you are giving 2 records. This is a bad way. You have to tune this well. How to tune it? We will see that. Any question? Any doubts? So as of now, we have discussed about what is the flow works, and also we will how to discuss about further more on this same. Now we have to understand in this example what are the column we verified during the stats gather. At this moment, I just mentioned blocks column and num rows column in this DB tables. Can I take the same view now here instead of now here? This is the one which I checked. Instead of this view, I can verify here DBA instead of tables, tab, statistics. Same view. One is DB tables and one more is DB tab statistics. What we call it as the columns are same, but the views are different. So now if I gather stats, let's say example here, execute dbm_stats dot gather table stats within the bracket. I pass this to well. Here you go. My table name is owner name is maybe Scott, and table name is DBT. Now go and verify here. This view also updated. This view also same well. So now the statistics information present in multiple places. So DB tables or DB tab statistics is just the view. So Oracle will refer these views and build the plan accordingly. Later, this views, what it has been maintained, we call it as E rows, estimated rows. We have certain called actual rows and estimated rows. That is what we will be discussing in the next class. Any questions here as of now?
So what is num rows, sir? Num rows?
Num rows is the number of rows in your table. An example, let's check here. Select here star from Scott.d. How many total rows I have? 4 rows. That's the 4 rows of the word is called your number of rows.
Okay. That means block 5 means that 4 blocks, 4 rows are consist of 5 blocks. That way it is.
Not guaranteed. So that means that's not guaranteed. Right now you need to remember it is initially given you for the table 5 blocks. But your row may not be guaranteed they are present in all the blocks, or maybe they are present in single block. So answer to your question, these 4 rows are maybe in the single block or maybe in the across the block. So for that to check, you can verify one more view called, or let me just show you. So this is my package dbms_row ID. From the row ID, you can use this package, and this package will give you pass the row ID, he'll give you the block number, in which block you have a record. Example, I'll say here. Initially, I'll just write down, I have a here row ID, and you have a here, maybe let's say row ID, and you may take all the blocks, maybe I may take here department number and department name, all the stuff you can see here. For example, I just take the row IDs these are the 4 different row IDs, but I will pass this row ID to my particular package. Tell this package dbms_row ID dot, and ask him, I will provide you row ID and you give me the block. So that's like here. row ID and followed by underscore block number. So say block number, passing the row ID, followed by, I can just check department number, department name from your same table. So now you just verified. So your previous question asked, I have a total rows in this particular table. How many blocks I have? 5 blocks. Is this 5 blocks will have this the 4 rows? Answer no. In output says that all the 4 rows are present in single block. What is that? All the 4 rows are presented in single block. Not right now it is in 5 blocks rather than in single block. Is it clear?
Okay. Yes, like a second.
Sir, it is reading 5 blocks to get this row, right?
Correct. Absolutely correct. Now you need to tell, is it reading only one block? Yeah, it is not reading one block. It is reading 5 blocks and to give you these 4 rows. In case of full table scan. In case of index scan, it will only read this particular block number 134, because index will store this row ID.
Sir, but the data is present on only one block, sir. Why it is reading the 5 blocks?
Initially, it will give you room to store the data many more. Later, it is saying that extent wise, one extent will be given to you. What is the extent is made up of blocks. What is the extent size? Extent size is actually 64 KB. So each block size is 8 KB. If you divide with the 64 KB with 8 KB, you will get actually 8 blocks. So out of 8 blocks, only 5 blocks has a high water mark. Remaining 3 do not have it. So above high water mark, there are 3 blocks still not right now given to you. But the extent is made up of 64 KB, but it is each block is 8 KB. That means your extent will say you have 8 blocks. An example, let's go for here. Just ask him, describe DB underscore extents. So extent says that this is my segment name and these are my extent ID and these are my block IDs. And if I type here, give me the segment name and this is my extent ID here, extent ID, and this is my blocks and these are my block ID. These are my columns which I just selected, and you can also check what is my file number, file ID from DBA extents, where your segment name is your DPT. Now ask him here, tell me where this DPT, how many blocks you have. Now here it says that you got 8 blocks and the extent number start with 0. Okay, so and your block ID starting with the 128. But now here, if I take the block ID with 128, so start with 128, then 129 and 30, 31, like that, you go with these many blocks. Now you take around these many blocks. So maybe you take here around 1, 2, 3, 4, 5, 6, 7, and 8. So around these many blocks you have. Starting would be your 128. So from out of these many blocks, your actual data present in here, and the remaining blocks are still initially given to you so that you can store the data. Exactly. And I can also check this all information in this particular. What it says that you can also check your object ID. Maybe you can verify here. What is my object ID? I may check. Give me the object. Describe your DB objects. There you will see this is the column name called database object ID. So let's now take this as object ID. Give me the object name and object ID from DB tables, DB objects, where your object name is your DB. So you may get this object ID. Now once you get the object ID, you can pass him, I have an object ID. You tell me how many blocks you have. Tell me, in this case, it says that we have a header. This is the header block number, and these are my data block. So 130, 130, 132, 33, 34, 35. So this is what it says. So 31 to 35, these are the 5 blocks where we have data. Out of that blocks, where is the actual data stored? Only in the block number 34. Is this
So what
clear?
is the status free and excursive something? What is the
Yeah,
status?
that we will see in the next class. Excurve stands for current, exclusive current, and free is nothing but where it's a free memory, not occupied anywhere. Exclusive current and free. And you may see that there is a options. Here is the one. Instead of this particular query, I may ask my table name, not this one. You may take the different table. Here, PH2 SQL. And now I will ask here, don't go with the same name. Owner name is, you ask runtime owner name, and you ask your runtime object. Now save it. So let's ask BS2 and ask him, this is my owner of the table and this is my table name. Tell me where is the blocks. He says that out of that we have a 6 exclusive current and 5 are free. So this you have to understand thoroughly. In our upcoming topic, I will explain you what is that meaning.
Okay, sir. So what I consider that instead of reading one block, it is reading the 5 block to get the data.
Correct.
That is the blocks, right?
Correct. That's a yes. That's a yes. All right, guys. That's it for
That
today's
is
session.
because of that is due to full table scan, right? The 5
It is
blocks.
because of full table scan. Yeah. If you don't go for full table scan, it may give you only specific block. Answer yes.
Index scan. Yeah. Okay.
So is the DML and DDL happened on this particular table, then the statuses will be going to state frequently. Is that right, sir?
Correct.
Is the multiple DML and DDL happened on this particular table, then objects of the statuses of the table is going to stale state?
Yes. 10% of your table gets changed, then the stats gets stale. Answer to that yes. It's correct.
10% rows we can conclude, sir, like how much, like 10% rows?
10% of the rows. Yes, you are correct.
Okay.
So let's say example, the 10% is the other one. Sayed, can you please remove the cursor? I'll just repeat here. You can do insert, update, delete, and truncate. So these are the 4 operations which we'll call it as a, let's say today you have 100 rows. Okay, so now you can say 10 extra you added, that is also 10% change. Or you deleted existing 100 out of that 10 rows, maybe it becomes now 90 rows. Or you updated those 100 rows, out of that only 10 rows you updated. Maybe you did an update also, you may do extra insert, or maybe you do existing delete, or you deleted all, it's called truncate. So all, if one of these operations, or maybe combined 10% also, it is called stale. So 2 insert, 2 update, and maybe 6 delete. So this is what we call 10%. Or 10 only insert, or 10 only update, or only 10 delete. It can be anything.
Okay. So when to consider the collect the status of the table, sir? When to collect the status of the table?
Yeah, that's a 10%. But is it really required or not? We will see. I will give you the answer for those in our upcoming with practical part.
Okay, sir. Thank you.
Okay. All right. That's it for today's session, guys. Let's catch you in the next session. So maybe there are few guys are joined today as a day 1, and any questions? Anyone has doubts to clarify as of now? Feel free to ask any questions. I will be happy to answer as much as possible. You ask the question.
Can you
So,
please
sir, as
so one more tell that
this. Okay.
One by one, please. Yeah. Kalim, you can go ahead.
Yeah. Okay, sir. As per you saying that we get the query result from PGA, right?
once you run the query, it will first check the blocks in the you can say in the data file.
Data
If it is
dictionary.
available in the data file based on the operations, if is it a direct read operations or non-direct read operations. If it is not a direct read operations, then it will first check it in the DB cache. If it is not available, he will take it from the data file. The second point, if you say that no, I have a direct read operations, example, it is a create table as selected. In that case, he will not take it from the DB cache, rather he will directly go to data file and take it and give it to your PGA. So once the PGA data given to my end user, the PGA will not have same data again. So again, next time if you want to read it, again you need to take it from the data file. The answer to that question. Is that clear?
Yeah, okay. Thank you. Yeah.
Thank you.
Sir, today I joined as a demo right now. I think this is the
Correct.
first class. Am I correct?
Yeah, this is just a demo only. Today also
Okay.
it's a demo only, not the actual class.
Okay. And one more thing, the recording chances will not be available. In this case, say whatever the commands you executed, this
This all will be shared to you with the output. Let's say example here, I will be sharing this all in the notes, and this notes also will be shared to you. Number one. Second, whatever I'm just storing here, the notes, which is also will be given to you, whatever I prepared for you. Plus, this all notepad will be uploaded, and you can also refer those. Is that clear?
Yeah, I got it. After this class, what and all we have the documents to refer, right? To understand we have
This all, yeah, day wise I will be sharing to you. So in that day, what we covered, what are the output has been referred or will be demonstrated, will be all uploaded in the Google Drive.
Okay, even what are the reports you have,
That-
open AWS reports, what
that-
itself for investigation you will be providing for all us, right? Yeah. Okay.
All right, guys. Anything
Question,
else?
sorry. Yeah.
Yeah.
So the scenario is, let's say user is reading 1 GB full table scan, is doing full table scan. The table size is 1 GB. And the SCA, you have, definitely you have good enough SCA to read the 1 GB table into the buffer cache. And from there, it has to go through the PGA and from their end user, right?
Correct. Yes, correct.
So reading 1 GB table into the buffer cache is easy because you have a good amount of memory, but PGA is limited. So there would be a
the PGA is
slowness, right,
limited,
reading
see,
1 GB.
what it does it, if you want to complete, give it to one go, still it is not given in the order wise, he has to push to temporary. Let's say if it is already not the order requirement, then it will directly give it to PGA to user, not necessary to push to temporary.
No group by domain. Okay.
Yeah, that whole depends.
My question is like, there would be a slowness, right, between
Yeah,
SCA
if it is pushed to temp to back to PGA, it's a little bit slow. Answer yes.
No, even from HGA to PGA also there will be a slowness, right? Because HGA you will be having in GBs, but PGA in MBs, right?
No, it will be PGA will not take entire 1 GB at a time. Rather, it will take row wise. Let's say it is reading from the DB cache first block. So those block record will be fetched from the SGA to PGA. Next, it will jump to the next block. Then it will take only those records. So that way, it will keep going with the next block wise and fetching to my PGA. So not you may feel it's a slowness, but it will be as quick as possible. Yeah.
Yes, but it's like row by row.
Row wise, yeah. Block within the block, it will fetch as per the row. Yeah. Answer yes.
Okay. But technically, we need to have a higher PGA. In case of full table scans.
Yeah, that depends on number of rows you wanted to proceed to process at the end. And again, that whole depends on whether you are looking for group by and order by. If not, then that PGA sizing is okay. So at the beginning, you can say the PGA allocation would be sufficient. Maybe once you started writing the query with the group by, order by, joins, in that case, we need a sufficient PGA. If not enough, he will take the space from your temp space. Yeah.
Okay.
Yeah. And also we have a AWS section where we can confirm that how many times it is visited from the PGA to temp. That also we can check.
This pre-built VMs will be provided, right, for us to practice.
Correct. This image will be given to you to download it, and later I will explain you how to build, how to set up your environment, and later from there you can start this all practice from your end.
Okay. In how many hours it will be going to complete in this?
It's a one class for building this machine.
No. Total course, how many hours? For
40 hours.
40
2.5
hours.
months.
Okay. In weekend only itself 2 days, Saturday.
Saturday 2 hours, Sunday 2 hours.
Okay.
And since it's a demo, right now it is only today has been covered.
Okay, fine. Yeah.
Sir, can we get at least this demo session for our recording? Can
That
you
I
please
will.
provide this, because sometimes we get miss here.
Demo sessions you want
This
recording?
one. Yeah, this one. Yeah, this one. Can you please provide the recording? At least
Let me
this one.
just. Yeah, I already have this recorded in the previous. Maybe you can search with YouTube. You may get that. Yeah.
Okay, then. Yeah, thank you.
Any other questions, guys? Before stopping for the.
So could you please provide that script which you are executing on this, on that all the
Definitely. Yeah, I will
to
share
find
it.
out this?
Yeah, I will share it. Don't worry. I'll share it.
Okay, sir.
Sir, the topic wise each documents will be provided, right? I mean, it's a
Correct. Absolutely,
PDF
yes.
documentation and whatever.
Yes. Whatever I'm referring, that with respect to topic wise will be shared to you along with the scripts. Yeah.
Okay.
And also keywords also, sir,
Obviously,
which we have
yes.
mentioned.
Correct.
Okay.
The notepad, whatever I'm writing, that all will be given to you.
Okay, fine.
And
Thank you,
in
sir.
detail, I'll be writing in the topic wise.
Yeah, that will be great. Yeah, thank you.
What happens if you cannot complete the course in 10 classes or
Sorry?
10
Again?
what happens if you cannot complete all the topics in 10 classes?
No. I never stop it until it is finished.
You would extend. Okay.
Yeah. There's no other, you can say choice. We have to.
Okay.
Sir, if anyone miss out the class for due to some personal reason or family reason, so can we get the recordings or can we refer as our own text
No,
files?
you have to record. You don't get the recording. Rather, you have to refer the notes.
Okay. So can you repeat in the next lecture for some parts?
Yes, obviously. Once you go through that, and whenever I start the, you can say the session, the previous session gets a recap, and then we'll start the further topic. Yeah.
Okay, thank you.
Any other questions? Okay, if not, then you just contact our backend team. They will help you out the start date and all. Yeah. And who are not yet enrolled, you can go ahead and get it complete the enrollment part.
Tomorrow will be the not start date.
Yeah, just check with the backend team. They will.
Okay, sure.
Okay, guys. Thanks for attending this the training session for our demo, and hope we will catch you on the actual class. Thank you, guys.
Yeah, thank you, sir.
Thank you very much to all.